Question number 2. It is given that fx equal to 2x minus 5 times x minus 2 squared. Find the coordinate of the stationary point on the curve y equal to fx. So we find the first derivative f prime x. Okay, so we have the uv, then the y prime will be uv prime plus vu prime. So 2x minus 5, 2x minus 1 times 1 plus x minus 1 square and then times 2. So we factorize the 2x minus 1. Then we have the 2x minus 5 plus x minus 1. So will be 2x minus 1 and then 3x minus 6. Okay, 6x minus 1 and then x minus 2. Okay, so stationary point when the first derivative equal to 0. So we have the prime x equal to 0. Okay, then we will have this 6x minus 1, x minus 2 equal to 0. So x minus 1 equal to 0, x equal to 1, x minus 2 equal to 0, x equal to 2. So f of 1 is 2 minus 5, 1 minus 1 square, which is 0. Okay, and then f of 2 will be 2, 2, 4, 4, negative 1, and then 1 square, which is negative 1. Okay, so we want the coordinate. So coordinate will be 1, 0, and 2, negative 1. Okay. Uh, so the fx is this. Okay. And we have the 1, 0, and this. So on this axis, we need to sketch the graph, and then at the same time we have to state the intercept. Okay, so for this graph we know that the um, maximum and minimum that we find is this two is the stationary point and then I know this is the local maximum, this is the local minimum, something like that. Okay, so the x, we have the 2x cubed. So the graph is something like this. Okay, positive. So go up. Okay. And then we have when fx equal to 0, then we have the x equal to 502 and x equal to 1. Okay. So we have the 1 and the 2.5. So 1, 2, 2.5 is something here. 2.5. So 2.5. So f of 0 is actually negative 5 times negative 1 square, then it's negative 5. So 1, 0, 2, negative 1. So we have the 2, negative 1. So negative 5. So this is the maximum. And the graph will something like this. Okay, so this is 2, negative 1. This is negative 5. Okay, so this is the local maximum. And the graph should look like this. Okay, so the graph that I draw is not that smooth, but the graph given in the answer scheme is something like this. Okay, so have negative 5, 1, and the 2.5. And the shape is like this. Okay, huh. So my scale is wrong already. Negative 1 uh should be somewhere here instead of here. This is like negative 3, negative 4 already. Okay, hence find the value of k which fx equal to k have exactly one solution. So over here, we know that this we have two solution, one, two, two. And over here, okay, this one, we will have one, two, three solution. So this is three solution. At this point is two solution. And then the minimum point here also have two solution. Okay, so this is negative one. This is negative one here. Okay, and then this part below negative one we have one solution. Above zero also we have uh, one solution. Okay, so the k less than negative one, and then at the same time the k greater than zero. Okay, so these two answer, k less than negative one and k greater than zero, then they have exactly one solution.